let us discuss details of PCR initially, basically why we are carrying out thermal cycling. Okay. So, PCR is a polymerase chain reaction, which is an in vitro technique used for create multiple copies of segmented DNA, which lies between two regions of known sequence. PCR amplification is accomplished by using oligonucleotides primers basically. So, although these oligonucleotides serves as a primer for DNA polymerase reaction and denatured strands of large DNA fragments serves as a template. So, we basically initially take a PCR mix in which these primers and different components like targeted DNA, primers, thermostable DNA polymerase, nucleotides and cofactor for DNA polymerase basically were mixed together to make a PCR mixed solution. After that we carry out the PCR reaction. So, the basic steps which is having like you can see here, one is native DNA, one is after heating we are getting denatured DNA. So, denatured DNA, these two strands are separated out. So, this steps happens to be at 95 degree centigrade or 94 degree centigrade. After that annealing happens. So, during annealing we carry out annealing for 55 degree centigrade or 54 degree centigrade depending upon the requirement of required gene amplifications. So, these primers 5 prime to 3 prime DNA strands of 5 prime to 3 primes binds together with two segments which were created during earlier steps on when during the heating. So, these utilizes reverse and forward primers to make a multiple copies of a templated DNA, and then basically the extension of these carry out during which the binding happens. So, only DNTP attached with the templated DNA. So, after that, so that way in a one cycle, so we are having two copies of like 2 to power 2, that means 4 copies in a first cycle. So, in a second cycle 2 to power 3 and likewise in a fourth cycle we have a 16 copies. So, that way exponential amplification takes place during the thermal cycling. Okay. So, up to the requirement how much cycle we need to be taken, we can count that, we can approximate that and can program into that manner basically how how much cycle will be required for this purpose. So, it will depend upon situation to situation of gene type etcetera. So, DNA polymerase, let us talk about DNA polymerase. DNA polymerase is an enzyme responsible for copying the sequence starting at the primer from the single DNA strands basically. So, commonly used we use there are different kind of polymerase which exists like tag generally we use tag polymerase, an enzyme from hyperthermophilic organism which is basically Thermus aquaticus isolated first at thermal spring in Yellowstone, that is basically created at national park. So, this enzyme is heat tolerant basically, that is why we are using it. Also we add for the heat toleration, we add these magnesium cofactor for DNA polymerase basically for the stabilization of these enzymes, and also oligonucleotides like DNT or DNTPs so that they did not get denatured. so to carry out the polymerase reaction. So, now we will focus on cut. So, as far we discussed about thermal cycling, we have to carry out to perform PCR reaction. So, here an instrument by national instrument which basically gives an opportunity to program graphically in coded form, so that we can maintain those temperature like we have discussed 95, 55 and 72. So, now we will have some small introduction about the LabVIEW, how LabVIEW works on the like information, how the information flow into the program. So, we will discuss about that. So, there are various different blocks, interfaces like for loop, while loop, etc., which is uses in word language like C, Java, etc. So, it is far different from that. It uses graphical language basically. So, the program is called VI, that means virtual instrumentation. So, whatever the program is made in the LabVIEW will be created in VI form. So, we call it VI, like virtual instrumentation. So, that means these are instructions which is given in a program to perform certain reaction, like suppose we want to monitor temperature of a particular thing. So, we need a thermocouple, and we also need a hardware which could be able to sense those temperature and to digitize those sense data and to give to the national instruments, and then it will come to the as per the programmed instructions. So, let us have a look at brief introduction on LabVIEW. So, starting with introduction to LabVIEW, LabVIEW program are called virtual instruments basically. So, it comprises front panel and block diagram basically. These two components are into that particular software. So, here you can see here you can see a front panel, this one is a block diagram. So, in which basically the information when we enter the value or some execution takes place. So, the information takes place, like here the program is made for conversion to C basically. We will give temperature into Fahrenheit, which will convert into centigrade. So, here basically a loop while loop is used, and then basically some multiplication factors are there. So, depending on those multiplication factors, it calculates the degree centigrade temperature, and it can be shown or displayed on the front panel basically. So, block diagram basically gives you the details of the particular program. So, general architecture of the these are three main steps, like we have to create like if from the point from where we are starting, and we have a while loop or a case structure or a for loop etc., in which we put some graphical instructions which already defined in the basically LabVIEW. So, we call those VIs and to create our program. So, here we have called it like numeric number, and here we called like stop, and here we have called the VIs of stop if the condition is true. So, so this is VI front panel. So, front panel it means like it is like a stop button is there, either it will be stop or will be start. So, it is operates like Boolean control, and this is double indicator. Double indicator means it is basically indicating the temperature which is shown in the history in the graph like waveform graph. So, this is front panel of that, this is block diagram of that particular thing. Like I already talked about, like we have called this sub BI, we have called sub BI which already exists in the lab view. Here the knob terminal we have specified which we have to stop or start. Here the numerical constant, like suppose we want to convert Fahrenheit to degree centigrade. So, which value has to be converted from Fahrenheit to centigrade. So, that value we have to enter it and then start, and so that will give you the output. So, that way here the thermometer terminal is called, and these are this is thermo temperature graph will be plotted over there, which is basically this shown on the front panel. And then after the calculation we can stop. The stop button is also provided here. So, that is shown here in the block diagram. So, these are basically main component of a particular lab view program. So, one is again I am repeating, one is front panel, other is block diagram. So, these are control functions palettes basically. I will be showing to you in the real software how from where which place you can find these functions and control. These are different controls which are available in the lab view. So, these can be a floating plates, these can be a floating palettes, graphical palettes used for different purposes like place control, indication to build a particular program which will be in form of block diagram. So, these are tools palette. So, there are different types of tool palettes, as I already discussed about that. So, these are the symbols which is shown there, like operating tool, positioning resizing tool, so labeling tool, wiring tool, shortcut menu, scrolling tool, breakpoint tool, probe tool, color copy tool and coloring tool. Okay. So, this is status toolbar basically which carries run button, continuous run button, then abort basically, and abort or execution of a particular program. Like if you want to pause the program, then we can pause this button, we can switch on this button to pause, and these are align object, distribute object, and this is a recorder. If you want, if suppose we want to record something during the cycle, so that way that can also be done with this particular button, this symbol which is available in status toolbar basically. Likewise, these are additional symbols which is available, which does different kinds of work for this. So, open and run virtual environment. So, we will basically firstly we will open and run the virtual instrument program. So, let us move to let us discuss about a single program. Like front panel have a value and B value. Okay. And so, now the operation has to be done like A plus B and A minus B. So, whatever the value entered in the A block and B block okay. So, that way it will add the value or it will subtract the value, and which will be basically will be done after execution of the program. So, let us see the block diagram of this. So, block diagram of like this will be like we have used here a multi subtraction symbol and then add signal, and we have provided these for providing the values we have a different sub BIs DVL. So, that way we can have those input call input tabs. Those tabs can there we can enter those values and execute. If we execute the program, it will give an output of a plus b and a minus b. So, that way this is very simple program basically to show you how these two panels basically works. So, here the wiring tips for the block diagram, like as you can see here in the block diagram, like this tab is basically this symbol is attached with this particular symbol. So, how the information will go to this place. So, the wire is attached to these two symbols. So, that the whatever the value is entered here has to be transferred to the next operator, which is basically carrying out addition. So, that is why these wires are connected. So, in the different language like C and Java etc., some parameters which carries the information, but here in a graphical language, these wires are basically forwarding the language from one BI to another BI or one symbol to the another symbol. Okay. So, these are I already talked about it. These are data flow programming basically, how the data will flow. I have already discussed about that. If we enter a number 1, number 2, it will basically after some operation it will give you some result which will be displayed on a front panel. So, likewise these 3 programs are there. So, that you can see. So, there are if you have problems on you are not able to understand what symbol stands for. So, you can go through the for help also that is available in the software. So, this is exercise 1 basically, where the degree centigrade has to be converted in the this VI converts basically a Celsius temperature to Fahrenheit basically. So, so these are debugging techniques. Debugging techniques means we before the basically execution of the program in a actual setup, we would like to have a look how the program will behave, how the information behave from one block to the another block basically that we have created for BIs. So, and then we can be assure about those things that okay, the information is flowing in a right manner, and all the BIs which were basically called in a creation of a particular program are executing properly. So, after for the debugging we carry out this step, and these are the sub BIs basically. Like sub BIs are a single BI which is called in main BIs file basically, in which we are programming. So, these sub BIs are called basically in particular main programs. So, they will work according to the their programming. So, these sub BI that can be used within the another NBI as I already discussed. So, these are basically advantages of that sub BIs. It is modular one, easier to debug basically. If some correct program is there, if we call it into a main program, then its program is already correct. So, it will be easier to debug that particular main program, it will be error free, do not have to recreate a code basically, and requires a less memory also. So, these are icon and connector basically. So, here we can see those connections are made from form of different wires like green and some orange type of. So, you can see mode and temperature. So, the connection basically made over there in a different form. So, here you can see here a complicated program. So, that utilizes different VIs basically. So, like one you can see here one BI is called, like here different BI is called, different like here different BI is called, and those sub BIs are basically assembling together in a sequential manner and making and giving you a complete program for a particular to complete a particular task. So, that way we sub BI are used. So, these are data acquisition systems, basically how we can data acquisition can be take place. So, we have a hardware components also in which basically we have those DAC devices, data acquisition devices, and connecting signals and simple data applications which inbuilt with the sensors. So, basically those acquisition devices send signal to the sensors, and those sensors particularly basically send signal to those DAC cards, and those DAC cards basically supply information to the LabVIEW interface. So, these are basically data acquisition systems in which plug-in board for a computer with analog input channels and analog output channels. So, these are and counters digital input output. So, these like simple temperature acquisition example is this, like two parameters I have device 1 or channel 0. Okay. So, device 1 which is called here 116, which will be a kind of thermocouple, will be measure the and in which channel basically this thermocouple is mounted. So, channel address is there. So, then channel address is there. So, that is where we are we have created this data acquisition. So, after the sensing the data will be displayed on the front panel. So, this is data acquisition terminology like resolution, range and gain. Basically, these are important factor for data DAC cards. So, like these are small some type of DAC cards which is used for different applications. Okay. So, again it is showing basically in exercise 2. Here you can see here the front panel is there, block diagram is there. So, the block diagram again it is converting those degree centigrade Fahrenheit to degree centigrade okay, degree centigrade to Fahrenheit. So, here also you are applying you are supplying these 100 degree Celsius, that is converting into Fahrenheit, and that is getting displayed on a thermometer basically on a front panel, which is this one. So, let us discuss about loops and charts. So, different loops and charts are used in LabVIEW programs like for loop, while loop and different charts and multiplots. Loops are basically having iteration terminal like the while loops basically having iteration terminal always runs one, always run once, run according to the continue terminal, while the for loop have a iteration terminal run according to the input value, whatever value you will provide, like you want to run a program suppose 10 times. So, you can enter the value n equal to 10. So, that way the program will run for a 10 cycle only, or 10 points only, whatever is required in the program. So, that way it basically differentiates whiles and for loop. Like here you can see, like here you can see you have supplied those charts. So, whatever the value are creating can be displayed on the chart, and here also you have provided like 100 value, while you have not provided here the value, because while loops works in such a manner that when you switch on it will run thoroughly basically until unless you stop it, while the for loop will basically will will run up to that particular cycle or a point which will you specify here. So, these are important loops on which whole LabVIEW program works. These are loop structures. So, these select like these are different loops basically shown here. So, here you can see this symbol basically shows a for loop. So, for loop basically if for loop is applied. So, here that way you can call here like this. So, if condition is given greater or equal. So, whatever a number is you supplied and number is there initially. So, if it is greater and then it will show to the front panel, or basically iteration take place depending upon the coded instructions. So, these are charts basically. So, whatever the value comes as a output can be plotted over a chart basically in various in form of different parameters in which you want to plot. So, these are symbols for plotting the graphs basically. These can be coded. These are the small BIs which already exist into the LabVIEW basically, which you call in the main program, which will create those charts. So, that way which type of chart you want. So, that way you can modify according to your requirement, like 3 dimensional study you want to carry out or 2 dimensional study you want to carry out. So, you can use those different charts for a different purpose. So, these are a wiring data into charts like single plot charts, and this is multi plot charts. So, if you see here like we have only a single string over there. So, temperature directly whatever temperature is there will be displayed over there in form of in the front panel, while here you have a 3 temperatures. So, here you have a bundle. So, suppose you want to create a different charts for every temperature. So, that way you can have a multiple chart. So, this is for creating those multiple charts you have a different symbol, while for a strip one chart for single chart you have a different symbol. So, that way you can have those multiple charts, and this is like monitoring the temperature. Okay. So, again this is the same program basically which we have discussed about. So, these are the array and file input output. So, sometimes what happens like values are created, different values, number of values are much more. So, we wanted to create a array of that basically. So, to make an array like 3 by 6 or 6 by 3 or maybe 10 by 15, 15 by 10 depending upon the requirements. So, we can create those array automatically as the requirement of the operation, and those created array values can be write down into the basically spreadsheet, and which spreadsheet can be opened into Excel or some WordPad. So, from that particular Excel or the Excel sheet or the WordPad, we can read those information how in which column and which row which value is there. So, that way we can see those values, and these are basically adding an array to the front panel basically. So, here you can have a different here you see a different symbols to control those array, like you can see here, like you want to have a 3 by 6 or 6 by 3 that you can define here. So, these are basically in the LabVIEW on the screen, like when you open the LabVIEW screen. So, you will have a control option there in which array and cluster there. So, there are sub palettes available by which we can create those array cells. Here you can see these are the, this is array and cluster, and like this way you have drop, you can drop on this particular symbol, okay, on the front panel. So, that way it will create an array automatically, but we have to provide how much row and column has to be there. So, that way we can have an array and cluster. So, this is for array and this is for cluster basically. So, adding an array basically place data object into the cell, basically a digital control. So, like here you supplied those array on a front panel. So, that will be displayed over there, and also the current value will also show to you. So, that way you can scroll down for the particular column and row which element is there, like C11 is there or C12 is there. So, that you can have, like suppose this is one row and 1, 2 and 5 columns is there. So, they have a different values. So, now suppose you want to call the number, suppose fifth element of this row. So, that way we can scroll down and can call this number by scroll down. So, that will show the what number exists at C5 basically C5 value. So, it will show you that particular value. So, that way you can have array systems. So, here you can see a single array, this is 2D array. So, here you supply these two values to scroll down to find out the basically which value is there in a particular column, because we have to call a row and a column to specify a particular element in a particular matrix. So, that way 2D array works. So, these are basically file input output in which read and write activity takes place. So, in which basically have a, like suppose you want to save a data over there. So, you have a save symbols, in which form you want to save it, that also available in a different symbols. So, that way you can read and create an output also. These are 2D array files, basically this is block diagram of 2D array files. Suppose you have a set of pattern over on the spreadsheet of a particular array. So, you can call those data which is available with you of a experiment which you carried out earlier. So, and you want to analyze for a certain thing. So, so you can call, like you can give a directory to the file, and this directory will basically will be called and will basically executed for the making those array, and then particular that array value can be utilized for the program purpose. So, this way you can generate the BAFE, suppose you want to create a BAFE form of that particular array. So, that you also can do that, and this is like analyzing and logging data. So, this is basically for analysis of data whatever you have got it during the execution of the program. So, you have a different, like suppose you want to have a mean value. So, you have a different symbols, and you, suppose you want to compare like maximum value and minimum value. So, that way you have a different symbol for that. So, that way you can analyze those data by the different symbols. So, these already I have discussed. Okay. Let us discuss about the strings, clusters and error handling. Earlier also we have discussed about the cluster symbols. what it is, we will discuss about that. String a string is a sequence of displayable or non-displayable characters in ASCII format. Many uses like displaying message, instrumentation control, file input output, string control indicator is in control. So, the string sub palette is there. So, that way one information can be transferred to the another place by the string. So, the cluster basically cluster is a data structure that groups the data together. Basically you have a different data together in at different place. So, if you want to put those data at a particular place together, so that way the cluster can be used. So, data may be of different types. It is very analogous to structures in C language. Elements must be either all controls or all indicators basically. So, though thought of as wire bundles into a cable basically. So, this one can be visualized those cluster situation. So, creating a cluster basically. So, there are palettes available basically. So, you select a cluster cell from array and cluster. So, here you can see the cluster is there. So, you can put those cluster on a front panel and then that way you can create those cluster. So, cluster function what it does basically. So, in cluster subpalettes of the functional palettes can also be accessed by right clicking on a cluster terminal basically. So, it basically suppose you have a two component like component 0 and component 1. So, in a particular cluster, so these value will be entered in a different form, those acquired value will be entered in a different form in a component 1 and component 2. So, in a cluster 1. So, that way you have a particular cluster and then also there is bundle thing basically. So, in bundle you have also a component A and component B. So, and these bundles are made by the can be made by giving those cluster values which basically will be has already obtained from particular place in the program. So, that way you can create those output clusters. So, that way the cluster function is how the cluster works basically. So, it is showing the basically cluster functions cluster if cluster is there, if it is unbundled basically. So, if it is unbundled then those different symbols are available into that particular thing basically, in which you can enter those numerical values and switch 1, switch 2 and string indicator is there. So, that way if you have a switch 1 and switch 2, so that way it will work on switch 1 work on a binary system, either it will be switch on or a switch off. So, it is comes into a cluster domain. So, there are error also which exist into a cluster basically, which needs to be taken care of. So, these errors are basically can be controlled through particular basically error clusters by putting some error clusters like here you can see those symbol is seen over there like these strings over there. So, here that way this handles the error in the clusters which has come due to some misplacement of the datas. So, that way suppose if an error occurs in suppose one sub BI, all subsequent sub BI are not executed in a usual manner. So, error cluster contains all error conditions basically. So, it has a particular data of particular errors, how many errors of the particular BI has been taken, has happened into that particular program. Okay. So, one more thing about LabVIEW. So, it also contains case and sequence structures. In case structures basically, it is analogous to if then else analogy, where we can carry out the a particular justification whether the condition is true or false. If it is not true, then this information will pass, or if it is true, then this information will pass, like that. So, in structures basically sub palettes of function palette, it is basically sub palettes, and close nodes of drag them in, like these can be put by from the software in the function palette, functions palette. So, like this window you are seeing. So, you have a false information or a true information, and inside it basically you make some operations. So, if that and then when you execute the program basically, so if the condition will be false, so it will show a different message. If condition is true, then it will show a different message. So, that way the case structure are utilized in the LabVIEW program, and these are error crystals, error clusters, how the error will be handled. So, again I already discussed, like suppose here you are basically calculating the square root. So, if there is to account, we have kept the value where the numeric value has to be greater than equal to 0. So, if that condition is not true, basically like if it is in -1, so it will give you an error. So, it will the error symbol will handle over this thing, and this whatever the error is there. So, that will be displayed here, like status is close basically. So, if error is not there, it is displayed like here there is no error. So, that way we can check in the program basically how if error is there or not, by keeping these error handling sub BIs. So, these are sequence structures basically. Suppose we want to run sub BIs in a sequential manner. So, that way then we use sequential structures. So, after a one sub BI, another sub BI will run basically. So, it will take a suppose we have two BIs like 1 and 2. So, if one BI is executed and it gives a certain output parameter, those output parameter has to be transferred to the second sub BI, and then second sub BI will give you a output as per your requirement, as you have designed those sequential structures. So, that way you can utilize sequence structures for your program purpose. So, these are windows, basically different windows you are seeing. So, here you can see here the no data is available, while here you can see temperature is there, sequence local created in frame 1 basically. So, temperature symbol you are seeing here. So, the temperature icon is called basically here. So, that way it is showing basically one frame. So, here one data is available. So, it is showing one data is there. So, since here there is no symbol is there or no icon is there. So, that is why no data is available. So, these are a formula nodes basically. So, these basically in the structure like sub palettes basically implement complicated equations basically, like suppose you do not have sub BIs. So, suppose you do not have sub BIs for a complicated equations. You want to have a calculation on that particular equation. So, you have certain parameters which need to be supplied in a program, and output has to be obtained. So, you can make you can type those equations and can put those x and y values and x values, and can be the y value can be displaced. So, here like you can see when you put a x value, you have to multiplication will take place, then addition will take place, and then you have supplied operator plus 1. So, one increment is there, like plus 1, one increment is there. So, that way this equation will execute it. So, it will give you a by value basically. So, on what x value this y value will be as a output variable. So, that way these formula nodes works. So, that is all. These are the printing documentation. After the running the program, you can print your data. So, that is discussion. That was the discussion, brief discussion basically. That was brief discussion on the LabVIEW. So, now we will have hands on basically or practical session on a particular thermocouple, basically how the temperature will change in a cyclic manner, as topic was thermal cycling. So, we will go to the practical, we will carry out the practical and we will see monitor how the data acquisition taking place, how the information is passing from one small sub BI to the another sub BI, etc. So, let us see that thing. So, let us discuss a practical session on thermal cycling. So, let us open LabVIEW file, basically it is programmed file thermal cycling. So, let us open it. So, now you can see, as we discuss in our PowerPoint slides, so here this is front panel, and if you go to the if you see here like file, edit, view, project, operate, tools, window, help. So, these are things available on this particular tab basically. So, here you can see window. So, window will show you the block diagram. So, when you click the block diagram, so you will see how the program has been made by utilizing sub BIs. So, here you can see like how these sub BIs are arranged in a sequential manner to carry out thermal cycling. So, here you see now suppose since we have a 3 temperature, okay. So, this 3 temperature, like if we go to the window front panel, so in which you have a temperature 1, temperature 2, temperature 3. So, to carry out a PCR reaction, we require a 95 degree centigrade temperature to carry out denaturation step. So, we will supply 95 over here, and then we have a annealing step. So, this is 55, and then we have a extension step. So, we have a 72. And then we also have a temperature hold time. So, this temperature has to be maintained for a certain period of time. So it is since it is optimized. So, we have found that 15 is a 15 second is the right timing to carry out denaturation step, and 30 is for annealing, and 40 second for extension step basically, 45 is for extension step basically. Since we have to carry out the extension step in which different DNTPs gets attached for making different making another copy of particular templated DNA. So, here we have a total loops basically. So, loops in which like one loop will be completed if these 3 temperatures on different time is completed, then one loop will be completed. So, that way suppose generally we carry out 20 loops or a 30 loops to amplify a certain PCR mix solutions for the detection purpose. So, let us say we have a 20 loops basically. For a practical session, let us take it for a 5. So, number of loops I have taken 5. So, before that I discussed about debugging basically. So, debugging is like when you go to the window, so debugging is takes place in block diagram. So, when you go to the block diagram, so this has to be understood basically. Whole thing will behave in this in a manner in which these BIs are placed in while loop or a for loop or in a case structure etc., which I already discussed in PPT. So, here you can see here this bigger one basically, bigger rectangular shape you can see here is a while loop. So, I discussed about this while loop. So, while loop, when you execute the while loop, it will run until you stop it. Okay. So, and this is another thing, this is case structure. This is this rectangular one is case structure. So, inside the while loop you have a case structure, and again inside the case structure, you can see here like this is again case structure, and here you have a while loop. So, you have 1, 2, 3, 4 rectangular shapes in which one is while loop, second one is case structure, third one is case structure, while other is while loops. So, whatever you are putting here those icons, that will be executed on that particular condition which is given in the while loop or in the case structure. So, like here this icon you can see, like this is start time basically, at what start time you have started, like in the front panel I have kept those value like 15 second. So, this clock will start over there once I executed the program, then it will calculate the elapsed time. So, then it will basically calculate the elapsed time and will see how, and this is temperature hold time, that how much time has to be holded, that basically. So, this value can be supplied through this icon. So, this icon is basically displayed in the front panel where I have entered that particular value, and so this way basically monitors the cycle basically, whether the 95, 55, 72 cycle has been completed or not. If not, then again this program will basically run again. So, here basically we have a 3 temperature zone like 1, 2, 3. So, I have supplied those 3 temperature, different 3 temperature 95, 55, 72. So, here you can see the icon. So, it is a Wandle basically. Wandle I have discussed about. Wandle carries different values basically. So, that is why it is used here, and here you can see the PID controller basically. So, here PID gains are available. So, in the PID proportional integration derivative, PID is basically compares those value which is as a output and basically compare the initial value which is entered, like temperature 1, suppose I have entered 95. So, it will basically monitor, it will sense the sense signal will come to the PID, suppose it is 80, and then it will say okay, this cycle is not completed. So, the temperature has to be raised. So, the gain will be the more gain will be there. So, it will multiply those things, and it will continue to the up to 95 degree centigrade. When it is 95 degree centigrade, so that PID will give the signal okay, 95 is reached. So, that is why you here you can see in the PIDs. So, these are different like time is there, dt, small output range is there, the PID gains is there, process variable is there. Okay. So, and then you have a re-initialization and then you have a set points. So, these are various parameters for the PID controller. So, that way this PID works for to control the those temperature which is basically has to be kept at suppose take 95 degree centigrade, which has to be kept at 50 degrees 15 degree centigrade. So, it will compare those outputs, and then will when it is reached to when the time elapsed is suppose 15 degree 15 seconds, then it will show okay, this 95 is there, then it will go to the next temperature. Let us see the debugging action. Okay. So, the highlights how the information will flow will be shown here. So, here you can see how the information will flow when we will execute from this icon like run. Suppose I run this. So, whole window is dull now, except this one, like this has taken value 5, which I have supplied number of loops, number of cycle which has to be completed, and then date and time is there. So, now the what temperature is supplied. So, it is giving those temperatures and the current temperature it is showing, you can see here which is around which you can show in front panel like 110 basically. So, which needs to be lower down. So, so it will basically automatically will lower down the temperature. So, here the information will flow, information is flowing like in from DC power, like it is measuring the current and voltage, whether the current and voltage is supplied or not. So, here see you see the timing, it is compared with the 15 second which is supplied for 95 degree centigrade, and then how much time is there, time is how much time is elapsed for 95 degree centigrade, and then it is basically again it is giving to the PID. PID is proportional integral derivative. So, it works on there are certain algorithm which is available given by given by different researchers. So, it works on like PID gains, how much gain is there, and proportional integration factor is there, and time and output range is there. So, that way the PID basically compares the value and try to stabilize the value which is required. Now, here you see if the statement is false, then if the statement is false, then those that the false case structure basically while loop is there. So, that will perform basically the task. So, here you see the information is flowing from this window. So, here that way here you are seeing again the set loop is there. So, the temperature, current temperature is 44, now it is set, and again it is plotted on a waveform, and now it is true. If the condition is true, so the PID controller is on. If condition is false, PID controller is not on. So, there are these two rectangulars you are seeing where the two given condition is there, like true and false. So, when the condition is true, so the PID controller will work for the stabilizing temperature for that particular amount of time, which is hold time given to in the front panel. Here you see the information is supplied to now the PID out is 1. Now, you see the information is flown to from NIDC power to these are the bundles which basically having the collecting the values, and these values are getting measured, which is measured current and voltage. And if these are these measured current and voltage will be supplied to that particular chip if it is required to increase the temperature. So, now current temperature is 44, you can see here. So, and here also in like now it is 77. So, here if you see on a front panel, it will also around this is 80. Now, this is 80, so that will also be 80 around. So, that way you can see now here you see like 72. These three temperature is there. So, here now the signal is sent to the waveform chart. Again the PID is working, that means the temperature is basically are getting monitored. This temperature which is needs to be monitored is 72 here right now. Again the temperature 2, temperature 3 information sent to this bundle, and this bundle is basically giving the information to the wave chart, and then on the wave chart the information getting plotted. And again you see if the temperature is how much temperature is required, you let us see how many loops are completed. So, if you see like temperature is 63. So, number of loops completed is 1. Here you see number of loops, I have supplied 5 loops has to be there. Now, 72 step is completed. So, it will go to the next cycle, which is will take 95 degree centigrade. So, now the temperature is getting increased, and let us see how the information is flowing. So, it is basically the false condition in which DC power will supply the current to the chip basically for the heating, I square RT heating, and then it will measure the current and voltage. Okay. And then again it will see the whether set loop are completed or not. If not, then the cycle will be repeated. So, here the cycle is executed, you see again you see these information are flowing from here, then it is sent to this place, that is waveform chart, and now see true condition is there, that means temperature has reached which was 95 degree centigrade. So, the true condition is on. So, that means now cooling has to be taken place. So, this is current temperature around 95, which PID controller has detected. PID controller has the value which is sensed by thermocouple. So, now the cooling will take place to basically, since we have to get the 55, we have to get 55 degree centigrade. So, the cool down purpose this the cooling has to be taken place. So, there will be no heating by the DC power which is of 12 volt battery, which is basically kept there and which is attached to the panel. So, here you see this this is NIPXI box. So, NIPXI has DMM module and DC power supply. So, DC power supply used for heating the chip, while DMM digital multimeter used for measuring current and voltage, and those measured current and voltage are displayed over here in the software. So, that value is plotted. Now, you see the heating has to be taken place. So, because here you see the temperature is around 55. So, this is 55. So, now the heating has to be taken place. So, the false condition is there. So, the false condition is there. So, that means heating has to be done for the to get the 72 degree centigrade temperature. So, here the DC power will supply the current required to the chip, and the voltage and current will be measured, and the cycle will be executed for that. And here you see again it is checking whether cycle is completed or not. If not, these 5 cycle is completed, with these 5 loops are completed or not, and so that way now the current temperature is basically okay. The current temperature is how much? You can see around 41 basically. So, why it is getting down? Okay. So, this is LabVIEW software. The BI is programmed. The name is thermal cycling, So, we are having 3 temperature zones for thermal cycling 95, 55, 72 and 95 is to be kept for the 15 second, 55 degree centigrade has to be kept for 30 second, while 72 degree centigrade has to be kept for 45 degree centigrade, and number of loops we have entered here 5. So, you are seeing that this value is changing. So, this value is changing, this is current temperature, which basically getting monitored through thermocouple for by the DAC cards. So, here you see NI instrument NI PXI 1031, which has DAC cards. One is DMM card, other is DC power supply card. So, DC power supply card is used for you see here DC power supply is giving to this chip basically, and this chip is basically the temperature on the chip is getting monitored through the thermocouple, and that thermocouple is directly attached to this DMM digital multimeter DAC system. So, it is acquiring data of the temperature and giving those values through the DAC card to the software, and that software is basically showing the temperature which is currently is available on the chip basically. So, here the power supply is there, and additional power supply is also provided here to take heating step as early as possible, since we require a sudden heating, a sudden cooling in PCR reactions. So, that is why this arrangement has been provided. This is whole setup. Basically, one is comprising LabVIEW software, and this is instrumentation part, other is basically the chip, which is basically getting thermal cycled utilizing these 3 systems. Okay. So, here you are seeing the software is running in which I have supplied total number of loops 5. 0 loops is completed, current temperature is showing 72 and 70, it is decreasing down. So, here you see the plot which is going down, that means the temperature with respect to the time is basically getting down, and that means the temperature which has to be there on the second zone 55. So, it is reaching to that value, and you see that value has to be maintained to 30 second. You see different tabs also here. So, here you see measured voltage, you can see here measure current. These measure current and measure voltage are coming from that DMM card basically. So, those data acquisition system. So, that value correspond basically getting these values basically giving the whether the how much current has to be supplied to the chip, so that I square RT heating could take place. So, now you see the this 55 step is basically completed, and now 72 step has to be completed. So, that is why you can see the increase in the graph, the increase in the temperature. So, now the 72 has reached. So, you see the current time elapsed time is calculating, it will be up to 45 degree centigrade, 45 second, for 45 second it will continue to heating on this particular temperature, which is 72, and during this current temperature what is the voltage and the current which is changing, that you can see here. So, the elapsed time is almost completed. I think it is 43, so it is 45. So, now it is showing, so these three temperature are completed. So, loop 1 is completed. Now, the again the loop second, that means cycle second. So, that means the temperature 1 has to be attained. So, now the heating takes place. So, during the heating you can see the measured voltage is 9.8 and current is basically 1, and here you see the temperature is increasing. Temperature is increasing, that can also be visualized by this graph. So, that way you can see on the real time basis whether how much temperature has reached or not. So, you see it is now reaching to the 95. When it will reach to the 95, it will have it will be held up to 15 second. Now, it is around 95. So, now the elapsed times tab is on. So, it will continue up to 15 second. So, you see around 10. After that, this temperature will be completed. Now, it is completed. Now, this step 55 steps, 55 degree centigrade has to be attained. So, the value is decreasing. So, now you can see the graph is also decreasing, graph is also decreasing. It will come to 55 degree centigrade. When it will come to the 55 degree centigrade, again it will be hold to for 30 seconds. So, that is way the cycle will be repeated. So, for more visualization we can see here one loop is complete, that means one cycle is completed. So, if 72 step is completed, then after the 72 step we will have 2 loops completed. So, number of cycle will be completed 2. Now, it has reached to 63 degree centigrade. Now, you see 58. Now, it is 55. So, this clock has started by counting to this 30 second. So, it will count 30 second. So, it is hold this temperature up to 30 second. So, this is annealing step basically. Next is extension step, and first one was I discussed about, this is denaturation of the DNA molecule. Okay. So, now the temperature is increasing from 72 from 55 to 72, it has to increase. So, now it is increasing. So, you can see this line correspond to the 55, okay. This line correspond to the 72 and this horizontal line correspond to 95. So, here you can see this dot. So, this dot, the temperature is increasing, it is 72. So, this clock is running. So, this clock will run up to 45 second. So, that it will reach up to this particular level. After the 72, number of loops will be completed 2. Okay. Now, you can see number of loop completed 2, the value is 2. So, that is how the cycle 2 is completed. One is this, second is this. So, the number of loops are completed 2. and the cooling and heating is basically carrying out on the chip. And let us see the execution of the program in the basically I talked about LabVIEW has front panel and the block panel. So, let us see the block panel. So, in block panel you you see how the execution is taking place. Let us highlight this thing. So, okay. Okay, so you see the information is basically flowing. This point. Okay. So, from this point to this point, here you are seeing those temperature. These are basically case structures in which true and false conditions are given, and it is compare whether loop is completed or not. If completed, then exit from the program. So, if heating has to be done, so if heating has to be done, then now the temperature is around 100 degree centigrade. So, here you will see the heating is there. So, the cooling needs to be done. Okay, this is 72. So, right now the heating is taking place. So, this is true condition. Here you are seeing the information is flowing from measured voltage, measured current, and from this to this place and then this place, and it is comparing whether the condition is false, loop there are two loops is completed, that is showing, and these loops has to be 5, which the condition is given here, then it will stop. So, here the information is flowing. So, now you see here this is thermocouple in which basically those different icons are used to program for thermocouple to acquire data. So, current temperature is showing 61 basically. So, here also you can see here 60 around. So, that way it is correct. So, here you see this is 60, on the front panel also it is 60. So, that way it is working. Also it is basically you see here the since thermocouple we have to provide the details of thermocouple type, reference junction, what is the reference junction, transducer type, resolution, what is the resolution, measurement type is there, that has to be defined for the thermocouple. So, that has been defined for the program. Okay. So, here now the temperature is 55. So, if 55 is there, so you see the true condition is there. Now, the heating will take place. So, and true condition is there, then I think true condition is there. So, the current temperature is around 48. So, in true condition 53. So, the heating is taking place in true condition, while the false condition if here the false condition is there, so the cooling will take place. So, these are rectangulars you are saying, these are the while loops, this is again while loops, this case structure, and this case structure and AND case structure, and this is our while loop. So, that way in which this PID will run up to that particular point where these temperature the number of cycles are not get completed. These are currently 2, which is shown here, this, and can also be shown when it is executed, the 2 cycles will be shown here. So, here you will see the current temperature. Okay, now it is 88, now it is 88. So, so now the PID it has to reach to 95, that is why PID is on. Okay, that is why PID is on. If it will reach to 95, then it will come down, then the false condition will on. So, the cooling takes place. Okay. So, so that way we have 4 rectangular blocks here and 1 block here. This is sequential structure in which the operation will be carried out like in a sequential manner. Okay. So, that is why this sequential window is kept here, and here again the case structure is there where the DC power is, another DC power is additional DC power is applied for the heating, as I told earlier also that we have used 2 batteries for the chip heating. So, here you see the current temperature is 57, and while you if you go to the front panel, you will see around 50. So, it is correct, and now you will see now you can see the value how the information is flowing. So, number of loops are completed 3. So, it is showing numbers of loops is 3. So, again loop 4 is started. So, loop 4 is started, that means current temperature is how much current temperature is 46. So, now current temperature is 46. So, false condition is on. So, false condition is on, that means temperature needs to be reached up to what? Temperature will be reached up to this 72. So, it is increased to 52, okay, and then 56. So, it will up to a 72 degree, then the loop will be completed. So, so it is 73. Now it is number of loops, how much? 3. So, it is 82. this is block diagram of developed program. So, here you see 4 rectangular blocks. So, in one block this is while loop, inside the while loop you have case structure loop, and here you have again case structure loop. There are two conditions available, whether it is true or false. So, during false there will be heating, and there is true there will be no heating. So, that way basically to control the temperature, the PID controller is basically PID is proportional integral derivative, which works on Ziegler-Nicholas algorithm basically. So, the PID controller basically compares the value, output value to the set value, like I have supplied temperature, different temperatures 95, 72, 55. So, during that heating and cooling conditions, it basically calculates whether the required value is has reached or not, and if it is reached, then it gives the information to the waveform chart basically. So, which gives you the output value, whether the cycle is there, cycle completed or not. So, and then again the cycle will run for a second cycle. So, that way here you can see a different window like this window. So, here you see the flat sequence structure. In a flat sequence structure, you see this is element basically, this is bundle basically, which contains a whole set of data which is coming out from the temperatures, temperature data and the current temperature data, and which is getting plotted over waveform graph, and these values whatever is collected in the bundle has been written in this by using this sub BI, which is called which is used for writing the values, and here again this bundle is used. You see the bundle information is coming from here to this bundle is again collecting those values, and this is basically spreadsheet where these value is getting written. So, here you see the date, time and temperature in the in this particular basically this is a string function basically. So, this is a string function which carries these 3 parameters. So, it works in a sequential manner as the name is as name suggests, this is flat sequence structure. So, this is another block which basically works on a basically this is again case structure. So, case structure may be true or false. So, if it is true basically it will provide the DC power to the system to the chip, while it is false it will not provide DC power to the chip. So, likewise here also if it is true DC power will basically supply will heating will provide DC power to the chip, while it is false it will not provide DC power. So, the heating of the chip will not take place. So, here you see again different block, you see this is while loop. So, in while loop you have a Boolean condition in which basically the current temperature is getting monitored through the thermocouple, and error is also getting monitored, like this is icon for DMM module. So, DMM module is called here to the value which will provide the value to 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 this particular place where the current temperature is getting entered, and this thermocouple is basically required this thermocouple is required to these different things to define, which is fixed reference junction thermocouple type, reference junction, transducer type, resolution digits, measurement and device name. This device name is thermocouple, which is already has been supplied. These icons you are seeing. So, these icons are used for basically DMM module. So, as I mentioned earlier also when we discussed the hardware. So, where the DMM is here the DMM module is called that by this particular symbol or icon, and here the range of the voltage which basically on which these voltage will be supplied, which basically transducted to the basically temperature, corresponding temperature. So, that is why this transducer type thermocouple is there. So, this is whole set of program here. You can see here cycle 1, cycle 2, cycle 3 is completed. It will basically monitored on the front panel. So, initially you see so this is whole complete program. So, case structure basically here the note point to be noted here, the case structures having the condition of true and false. So, as I discussed in PPT, and while loop does not have those these things because basically while loop works on a principle like it will run up to that the point until you stop it. Okay. So, because we have not provided the condition, but under the while loop we have provided the condition by providing the case structure. So, that is why the temperature is getting monitored and timed for a particular duration by which thermal cycling is being carried out. Okay. Thank you.